Well, we already did 5/8 part 1, which was parallel lines. 5/8 split into two sections, half parallel lines. Now we're going to talk about perpendicular lines. Now, what do you guys know about perpendicular lines as of now, up until now, I guess? Mr. Cummings, what's so special about perpendicular lines? Do you know? Intersections, for sure. They're not going to have the same slope, definitely. So since the slopes are going to be different, they are going to intersect, but they're going to intersect in a specific way to make what? Shimon? Exactly. Angles at your intersection are 90 degrees. You make 90-degree angles. Okay, so that's perpendicular lines. Now you kind of signify that by doing like a little box, because we know rectangles have 90-degree angles. So if you make a little rectangle there, that signifies that that's a 90-degree angle. You'll do that more when you get to geometry next year. All right, so let's look at maybe an equation. A simple one like 3x plus 2. Y equals 3x plus 2. Looks like this. What do we think the equation of a perpendicular line would be? Yes. Y equals -3x. Right? That would totally be like a legitimate guess. The opposite slope, right? Flip it, maybe. Let's look. Do those look like 90-degree angles? No, it doesn't. This is a little bit bigger than 90-degree angles, and this looks like it's smaller. So it turns out the slopes are not opposites of each other. Okay? Well, let's look at these two lines. I'll tell you right now for sure that these two lines are perpendicular. We'll calculate the slopes of these two lines. This line has a point here and a point here. I can use rise over run to find the slope of this line. This line has a point here and a point here. I can use rise down over run to the right to find the slope of that line. And then let's analyze those two slopes and see if we can find the right slope for 3x plus 2. Mr. Jacoby, what did you get for the slopes? What's the slope of this line? Yep, 2 over 1, which is just 2. And then what's the slope of this line? It would just be 2. 1, 2. All right, so those two lines are perpendicular. The first line has a slope of 2. The second line has a slope of -1/2. So let's go back to my equation, y equals 3x plus 2. What do you think this has to be for this equation to be perpendicular with this one? What do you think, Ms. Cordova? Well, let's see, 1/3, second insert, 1, change that minus into a divide. Doesn't look perpendicular. You're missing one thing before the 1/3. Mr. Orsic? -1/3. Notice how this is +2. This is -1/2. If this is positive 3, this slope of this perpendicular line needs to be negative 1/3. Now we're going to see something interesting here. Do those look perpendicular? Kind of, but not really, right? It looks like maybe this angle is a little bit less than 90 degrees, and it looks like this angle might be a little bit more than 90 degrees. Anybody have a guess why it doesn't look? I'll tell you that these lines are definitely perpendicular that we just graphed. Why would it look like it's not? What do you think? Yeah, it's where the numbers are on the y-axis compared to the x. Notice how your screen is a rectangle. It's not a perfect square. But in this rectangle, we're fitting in 10 units and 10 units in a smaller distance than we're fitting to the left and to the right. So I'm fitting in 20 units from left to right, and I have more space to do it than I have to fit in 20 units up and down. So it's really, really important when we're doing and analyzing perpendicular lines that we don't look at our calculator. Our calculator is going to be deceiving. So make sure we write this down. I'll show you kind of an example of like what your calculator does. Do this with the other class. I thought it was a good example. Let's get a picture of perpendicular lines. Here, these look like perfectly perpendicular. Maybe not perfectly perpendicular. Those look better. Yeah, let's use those. What your calculator does is they take this square image, okay, and it shrinks it this way to fit it into your screen. And the more you shrink something, the more skewed it's going to look. All of a sudden, this angle here looks to get bigger and bigger and bigger, even though it's 90 degrees. Because it's shrinking it and it's skewing it. Notice how the top angle is getting bigger. It looks like this right angle on the right is getting smaller. Well, it keeps happening like that, even though these angles are 90 degrees. It's just a skewing of the image, which kind of makes it tricky. So this is why when we're trying to figure out whether lines are perpendicular, we're not going to use our calculator. Instead, we're going to understand the relationship between the slopes of the perpendicular line. Okay, and here's the relationship. Perpendicular lines have opposite reciprocal slopes. Well, geez, Mr. Messner, that sounds great and all, but I have no idea what that means. An opposite reciprocal slope is just, you take the slope of your one line, you change the sign to make it opposite, all of a sudden this becomes negative, and you flip your fraction, and you have negative 1/2. Being an opposite reciprocal means change the sign, flip the fraction. Yeah, but Mr. Messer, if I have a slope of 4, that's not a fraction. How can I flip a fraction if I just have a number? Mr. Orsic? It is a fraction. It's 4 over 1. So if I have a slope of 4 over 1, Mr. Orsic, what would be the slope of a perpendicular line? That's it. So simple. The slope of a perpendicular line, and now this upside down capital T is the mathematical symbol for things being perpendicular. So if this is a slope, the slope of something perpendicular, you can write like this. Slope of something perpendicular would be equal to negative 1/4. Mr. Stalker, if I have a slope of negative 2/3, what would be the slope of something perpendicular? Positive 3 over 2. Well, how are we going to remember this? We got a nice little hand thing for parallel lines. Parallel lines equal slopes. Well, we got something for perpendicular lines. Hold up your perpendicular lines. Make sure they're kind of up and down. That way you see a plus sign, okay? Give me just a little pump, just like that, slip pump. That pump, that's change the sign, okay? See the plus sign? Plus is like a sign. Pump it, you're changing the sign, okay? And then flip the fraction. Parallel lines equal slopes. Perpendicular lines, do it, Mr. Kidder. You're not cooler than me. I know that for a fact. Change the sign, flip the fraction. Okay? All right. And now, when you're taking your test, you don't have to use your hand. You can use your fingers. Okay? Everybody, fingers. Parallel lines. And you don't have to let anybody see you. Okay? Equal slopes. Perpendicular lines. Change the sign, flip the fraction. All right. Good. That way you can stay cool, Mr. Kidder. Almost as cool as me. All right. Here's 5 slopes. Give me the slopes of lines perpendicular to these 5 slopes. That last one's a little tricky, but the other one should be all right. The last one is not 0. I'll let you know that right now. The answer to the last one is not 0. How do I flip -1? Can't flip this fraction. Well, now it's a fraction. Flip it, change the sign. It's just positive 1 over 1, which is just positive 1. Whenever you have something divided by 1, just give me the whole number. Okay, that way you don't have unnecessary fractions. 3, that's 3 over 1. You know, I'm going to ask you guys. Let's go pick a number between 1 and 6, Mr. Miller. 6. Between 1 and 6. Pick a number between 1 and 5. 3. All right. Good pick. Ms. Sanchez, what did you get for the second perpendicular slope? Perfect. Ms. Wells, third one. Perfect. Mr. Kidder, fourth one. Good. 5 over 1, which I want you to change to 5. 5 over 1 is just 5. Did you get the perpendicular slope of 0, Mr. Lake?
-1/0.
-1/0 is correct. But what is something divided by 0? Exactly, Mr. Miller. It is undefined. If I try to plug in -1/0 into my calculator says no. Can't do it. Let's think about this last situation. What would be an equation of a line that has a slope of 0? What would that line look like? Let's see. Visantes. Y equals 0x plus 4. What does it look like? Graph it in your calculator. Zero x plus 4. A line with a slope of 0. So it's essentially just y equals 4, right? What's it look like? Yeah, it's a horizontal line. If I have a slope of 0, this gives me a horizontal line. What must a line be with an undefined slope if it's perpendicular? What do we think? Mr. Jacoby, what do you think? Not sure? What would be a line perpendicular to a horizontal line? Mr. Avila, what do you think? What does it have to look like? What would be perpendicular to this line? Something that goes what? Yeah, it would kind of be opposite of it, so it would be what? In what directions? Yeah, it would be up and down, right? A vertical line. Well, vertical lines have equations x equals a number. Vertical lines have undefined slopes, okay? That's that situation. Horizontal lines and vertical lines are perpendicular. This line is perpendicular to this line. Okay? Cool. Well, now I'm going to give you an equation, and I'm going to ask you, what's the slope of an equation perpendicular to this line? What do I have to do? What do you think, Mr. Miller? Solve for y. Yeah, solve for y. Because unless you solve for y, you don't even know the slope of this equation. And we know that perpendicular lines have this special relationship with these slopes. So we need to find the slope of this line. Once I find the slope of this line, I can now figure out the slope of a perpendicular line. What's the slope of the perpendicular line, Mr. Miller?
5/5 -5/6.
Exactly. Change the sign, flip the fraction. All right, you guys do the next 3. Check your answers with neighbors. Check that one again. And that one. All right, I want to see everybody checking. Are you checking? Do you all check? Check. If you haven't checked yet. Okay, I did that row. Let's do row number 1. Miss Aaron, I already called on you. Mr. Cardenas, what is the perpendicular slope to this equation? Beautiful. Miss Cordova, what's the perpendicular slope to this equation? Perfect. Mr. Victoria, did you get this one? You are almost there. The only problem is when you solve for y, you get negative 3x plus 2. So this has to be positive 1 over 3. Okay? But good job, you guys. This is y equals 4x plus 15. This is y equals negative 5/8x plus 10/8. Sweet. Well, let's put it all together. Let's not only find my perpendicular slope, but let's use this perpendicular slope to generate a new equation, and this new equation is going to be perpendicular to this given equation. However, my new equation is going to have to pass through this point. Okay? So, it's kind of like what we did last class. There's just one little change. The only little change is instead of using the same slope as this equation, you're going to use the perpendicular slope. Okay? This is the slope of this equation. That means the slope of my new equation will be negative 2 over 5, right? Change the sign, flip the fraction for perpendicular slopes. So my new equation has to have this slope, and my new equation has to pass through this point. How do I develop a new equation with a slope and a point? I use my helper equation to help me find what the y-intercept is, so I have a y equals mx plus b equation. Y minus 4 equals negative 2/5 x minus negative 3. That's immediately plus a positive. We distribute. Negative 2/5 x plus negative 6/5. And then we add that 4, and we get y equals negative 2/5 x plus. That's 20/5 plus negative 6/5, which is 14/5. Okay? Well, that's great, but why don't we check? In my calculator, I can graph 5 halves x plus 6. And I can graph negative 2 fifths x plus 14 fifths. There's my first equation. My second equation should look fairly perpendicular. It's skewed, so it's not going to look perfect, but this looks pretty perpendicular. And then I go into my table, and I see, does this second equation pass through negative 3, 4? And it does. Okay? Well, why don't you guys do this third one? Now, for the third one, the slope of that equation is not negative 3. Solve that old equation for y first, and that will be your slope. Slope is the number next to x only after you've solved your equation for y. That line's parallel to this line. I want a perpendicular line. Okay. This line is parallel to that line. I don't want a parallel line. I want perpendicular lines. Think about what slope you're using. All right, do that one. You can do it. This will be a parallel line. Good. 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 Make sure you're changing the sign of that slope, not just flipping it. Good. Good start here, but you need this point and this slope. So you need the helper equation. Y minus y1 equals m times x minus x1. Didn't flip your fraction. A lot of people have been doing problems like this. The problems we did last class, and for homework, you immediately like, oh, hey, this is a slope here. I'm going to put that right here for m. And I have x minus x1, and I have y minus y1. This is different. I need a perpendicular line. So I'm not using the same slope. I'm using the slope that is the opposite flipped. Negative 1/3 will be the slope of my perpendicular line. Y minus 0 is just y. This is negative 1/3 x plus 5/3. All right. Sweet. Next page. Let me give you a tough one. These aren't that tough. Let's do this one. Middle one. Make sure we hold on to our notes too. We'll do some practice problems next class before we take our quiz. Review day next class. We're finally done with this second half of chapter 5. Test next Thursday. and we review for midterms, and then you guys have your midterm on Wednesday. Check your answer with a neighbor. Make sure you're using that correct perpendicular slope. Make sure you're using plus and negatives. Taking care of your signs. Make sure we find the correct slope. If this slope is 1, the slope of my new equation needs to be -1, which is the fraction flipped and opposite. All right. If we all can do this problem correctly, we will stop there. Go. Good. Actually, when you get the right answer, you can back up. Good. But I gotta check to make sure you get the right answer, Mr. Stalker. You can't just assume. Oh, yep, got it. That's right.
I assume I got it right.
All right, you got it right. You're good. I see a lot of people using the slope -3/1. Don't use this. Use -3. -3/1 is the same as -3. Okay, when you're multiplying everything by -3/1, it's just unnecessary stuff. Your last step's incorrect. 13. Your last step was wrong. Check your last step. No, this is positive 1/3. Right, because you added 1/3. So that this needs to be -3/1. What's your last step? You added 3, right? This is already positive 3. How do you get rid of positive 3? Either subtract or add a negative. Good. 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 You're almost there, Mr. Dishon. Good, Mr. Gibson. Good job, Mr. Rodriguez. Good job, Mr. Miller. Good job. You're almost there. Now, here's the problem. -3 times -15. That's a -15. So I tell you, turn this to plus or negative. That's a positive 45. 45 minus 3 is 42. That's it. Subtract 3, 42. Okay, that's it. Everything else is good. Good. Sit down. Wait till this turns 10:13, then you can stand up and leave. -15 times -3 is not -8. You have to multiply first before you add. Mr. Jacoby, did you get the answer? I need to see it. What's M? What's M? X. It's MX. X times X. This should be X minus 15.
Oh, okay.
So this should be plus 45, and this should be plus 42. Okay? That's good. All right, have a wonderful weekend. See you guys on Tuesday.